Okay, so today we're working on parallel lines. Okay, what are parallel lines? Well, everyone kind of knows what parallel lines mean because we've all seen train tracks where the two rails, the two big pieces of wood, run parallel. They run beside each other. But in terms of equations and lines, what does it mean? So let's take a peek here. So we're going to fill in the chart to start. We'll start with the green. So this will be green. This will be blue. This will be red. Okay. Starting with the green, what's the slope? So let's pick 2 points here. Let's pick this spot and this spot. Okay. A little smaller here. So we're going to go up 1, 2, 3. We're going to go over 1, 2. Good. So 3 over 2 is my slope. What's my equation? Well, I'm going to write here. Where should I write? B equals 1, 2, 1, 2, 3, 4. B equals 4. So my equation is going to be y equals 3 over 2x plus 4. There's my m. There's my slope. There's my y-intercept. All right, next up, blue. I'm going to pick this spot here and this spot here. 1, 2, 3. 1, 2. So my rise is 3. My run is 2. My b in this case is 1. Y equals 3 over 2x plus 1. Okay. Last one, our red. So I'm going to pick here and here. So 1, 2, 3, 1, 2, 3, and 2. Okay, what do we see that's all the same here? Okay. All three slopes or rates of change have all been the same. In this one, my y-intercept is -2. Equation is 3 over 2x minus 2. So, what do you notice about the graph? Okay. So, where's my pen? So we notice, actually use here for this, since my writing is messy. We notice that 1, or A, all the slopes slash rates of change are the same. B, the y-intercepts are different. Okay. So what do you notice about the lines? Well, all the lines are, and I'm horrible at spelling this, that's not how you spell parallel. All the lines are parallel. Okay. So all these lines are parallel, like they're never going to cross each other. You can see they all go up at the same rate of change. Okay. What we noticed was the slopes of the rate of change are the same, but the y-intercepts are different. So we could say a rule for parallel lines is they have the same rate of change and different y-intercepts. Oh my gosh, this isn't my regular computer. Okay, now, if they had the same y-intercept, they wouldn't be different, they'd be the exact same line. Okay, that's why you can't have the same y-intercept. So, I want you guys to give a shot of these ones here before I write them down. Given these lines, write a line that is parallel. Okay, so pause it here, give it a try, and then bring it back to me here. then turn it back on. So for this one, a line that is parallel is going to be y equals 3x plus any number you want. Okay. The number could be, for example, I could write 4 in there. Okay. I could write 22. I could write 8 million if I want. It just cannot be, it cannot equal 2. So any other number but 2 works. For this one, so we need the same slope or rate of change, so negative 2 over 5 x, and it can be plus or minus any number. The one number it cannot equal is negative 3. So I'm going to put, let's go plus, and I'll go, my favorite number is 44. And the last one, this one's mixed up a little bit because this is the slope. This is the rate of change. Okay, remember the rate of change is always beside the variable. So let's write it down here. Now I like to write the rate of change first. So I could just change it up and write like this. And then I'm going to write minus 3 because the only thing it cannot equal is positive 3. So anything else. So just remember, parallel lines have the same rate of change slash slope and different y-intercepts. So that's parallel. Perpendicular lines, okay? Perpendicular lines are lines that meet at a 90-degree angle, okay? So these lines cross at a 90-degree angle, right? A perfect 90. So let's take a peek at these two lines and see if now we know they cross at 90. You can trust me, hopefully. I'm not setting this whole chart up just to mess with you. So where's blue here? This will be my blue. So my slope of this line, so let's pick 2 points. I'm going to pick this point and this point. Let's go rise over run, so down 2 over 1. So my rise over run is negative 2 over 1, which I can just write as negative 2. But I'm going to leave as 2 over 1 right now. And my b for this one is 1. That's where it crosses. So my equations would be negative 2 over 1x plus 1. Okay. Then my red one here, let's pick 2 points. Let's pick this point and this point. We're going to go up 1, my rise of 1, and my run of 2. So rise of 1, run of 2. And my y-intercept for this one is going to be minus 1, minus 2. It was negative 2. So my equation for this one is 1 over 2x minus 2. So what do we notice about the slopes? Okay. Well, 2 things. Notice 1, they're opposite signs. Right? They're opposite signs. As in, 1 is negative, 1 is positive. Okay. 2, the numbers are flipped. Okay. So we had 2 over 1 flipped to be 1 over 2. And I left out the positive negatives there. Okay. What do you notice with the lines? They meet at 90 degrees, which we talked about earlier. So, perpendicular line rule, line slopes are, now this is, I think we've talked about this before in class, It's called a negative This is why I don't teach English. Negative reciprocal, which means, okay, you flip the number and reverse the sign, okay, which will go over here. So for example, if we have a slope of 4 over 3, our negative reciprocal is we're going to flip the number. So 4 over 3 changes to 3 over 4. And this here is a positive number. So we're going to make this one a negative number. So it's minus 3 over 4. Okay. Now, we're going to kind of put these together. I'm not going to worry about this part here. We're going to cross these out. We'll take a look at it real quick. So let's say I have a slope of 1 over 2. Oh my, what just happened there? If I had a slope of 1 over 2, where's my mouse? 1 over 2. So the reciprocal of that, the parallel line of that would be negative 2 over 1. Okay? So we flip it, change the sign. Something neat happens here if you times them together. If you multiply these together, or we multiply straight across, we're going to get negative 2 over 2, which equals negative 1. Okay? Let's show it again. So let's say we do the one above, which is 4 over 5. Okay? Then we're going to do the negative reciprocal, which would be 5 over 4, which equals 20 over 20, which equals negative 1. So if you multiply two slopes together, and you want to know if they're really perpendicular, if you multiply the two slopes together, you'll get a negative 1. So I want you to pause it here. I'll show you the first one, then I want you to do the rest after you pause it. So this line here, these two lines here mean parallel. So let's find a slope that is parallel to this. Well, it's 3 over 4. A slope that's parallel to it is going to be 3 over 4. A slope that's perpendicular to it is going to be flipped. So we're going to reverse it, and we're going to change the sign. So this is a positive. So we're going to make this a negative. So pause it here and see if you can do the rest of these without any help. All right, you're back from pausing it, or you're cheating and not pausing. So parallel, we're just going to write this slope again. It's the exact same slope. Reciprocal, we're going to flip it and change the sign. So it's negative there, so we're going to give it positive here, and we're done. You can also write that as a 2. This one, let's keep the same, so we get 2 over 3. Perpendicular, we're going to flip, and we're going to change the sign. So this is going to be negative. This one here, keep it the same, it's going to be 1. Now, this is going to be, hypothetically, this is 1 over 1. So when we come over here, it's going to be 1 over 1. But we're going to change the sign to be negative. Last one, negative 5. Now remember, there's an over 1 there. So this is going to be 1 over 5. And this was negative, so this is going to be positive. And that is it. You have today, I think a Desmos activity to work on your parallel lines. Okay, have a good day.